Hello everyone, this is my fifth video in this topic, that is balancing redox reactions by ion-electron method. So let's see what is example number 5. Here we will deal with a reaction. The reaction is Zn plus NaNO3 plus NaOH giving Na2ZnO2 plus NH3 plus H2O. Okay, so zinc is reacting with sodium nitrate in presence of sodium hydroxide to give sodium zincate, ammonia and water. So as sodium hydroxide is present in the medium, the reaction is in alkaline medium. As I said in my earlier video, in the reaction in acidic medium, there I said that in acid medium you should use only H plus and water molecules for balancing the half reactions. Here the reaction is in alkaline medium. Here you cannot use H plus ion, you have to use OH minus ion and the water molecule for balancing the half reactions. So first write in the ionic form zinc plus, here it will be plus and minus, so NO3 minus in presence of OH minus giving, here it will be 2 negative because 2 sodium ions are there, ZnO2 2 minus plus NH3. NH3 should be written as it is, means it is a covalent compound, so we have to write the full formula. Okay, water will come after we balance the reactions. Okay, so the changes are Zn is going to ZnO2 2 minus and the NO3 minus is going to NH3. Okay, let's take the first process, that is Zn going to ZnO2 2 minus. Zinc is balanced, but 2 oxygen atoms are extra in the right hand side. For balancing oxygen atoms in alkaline medium, we should add the equal number of water molecules at the side in which the oxygen atoms are extra. In the acidic medium, the rule was little bit different, because in that case we were adding the water molecules in the opposite side, but in alkaline medium we will add the water molecules at the same side at which the oxygen atoms are extra. So we will add 2 water molecules here. Now you see 2 oxygen and 2 oxygen means 4 oxygen atoms and 4 hydrogens are extra in the right hand side. So for that, if we add 4 OH minus ions, these will balance all the atoms in the both sides. Okay, now we will look at the charge. Here 4 negative ions are there and here 2 minus charge, so we have to make 2 negative charge only at the left hand side. So for that, if we remove 2 electron, then it will give 2 negative charge which will be balanced with the right hand side charge. This is done. Now the second process, NO3 minus going to NH3. Okay, here 3 oxygen atoms are extra and here 3 hydrogen atoms are extra. Nitrogen are balanced, 1 nitrogen 1 nitrogen. So first let's balance the oxygen atoms. Okay, as I said earlier that the side at which the oxygen atoms are extra, we will add the equal number of water molecule. So here we will add 3 water molecules. Okay, now we are getting 6 hydrogen and 6 oxygen atoms. So for that we will add 6 OH minus ions at the opposite side, that is the right hand side. So oxygen atoms are balanced, but hydrogen atoms, 3 hydrogen atoms were already extra earlier. So now we have to balance these hydrogen atoms. The process is, or the rule is, if after adding the water molecules and the hydroxide ions, if hydrogen atoms still not balanced, then in that case you should add the hydroxide ion in equal number, means number, the hydrogen atoms here 3, so we will add 3 OH minus ions at the same site. Okay, now for these 3 hydrogen and 3 hydrogen means 6 hydrogens and 3 oxygen. So for that we can add 3 water molecules at the opposite side, that is left hand side. So it will balance everything, means oxygen atoms and also the hydrogen atoms. So we can write this reaction as a overall reaction as NO3 minus plus 6H2O giving NH3 and 9 OH minus ions. This is the reaction only balancing with the of the atoms, but not charge. So we have to take care of the charge. Now here you see at the left hand side is 1 negative and at the right hand side is 9 negative. So we have to make overall 9 negative charge at the left hand side, and already 1 negative charge is there. So if we add 8 electrons, that will make 9 negative charge at the left hand side and it will be balanced with the right hand side. Okay, now the half reactions are balanced. So we can assign the half reaction type, means here electrons are subtracted, so it will be oxidation half reaction, and this one will be a reduction half reaction. So now our task is we have to add these oxidation half reaction and reduction half reaction to get the overall balanced redox reaction. Okay, you can remove now this one, because already the actual reaction is written here. Okay. So for adding, what I said earlier also, that we have to add in such a way that after addition there will be no electron left in the overall reaction. For that we have to multiply both the reaction with appropriate number, and at the end there will be no electrons left. So let's assign this as number 1 and this one as number 2. Okay, so if we do the number 1 equation with multiply with 4 plus number 2 equation reaction into 1, then what we will get? Here you see we are multiplying with 4, so it will give 4Zn plus 16 OH minus 8 electron giving 4Zn O2 2 minus plus 8 H2O. Now the second reaction we can write as it is, because we are multiplying with 1, so it will give NO3 minus plus 6 H2O plus 8 electron giving NH3 and 9 OH minus ions. So let's sum up, this will be cancelled and we are getting 4Zn plus NO3 minus plus OH minus. Now you see here 16 OH minus and at the right hand side we will get 9 OH minus. So overall there will be 7 OH minus ions, and it will be in the left hand side. Now water molecules, 6 water and here 8 water is there. So there will be 2 water molecules, resultant 2 water molecules, that we will write at the end. Okay. Now 4Zn O2 2 minus plus NH3 plus the water molecule, that will be 2. Okay. This is the balanced redox reaction in the ionic form. Now we have to convert this reaction into molecular form, because the reaction was given in the molecular form. So let's convert that balanced redox reaction into molecular form. Okay. Here 4Zn, so zinc will be as it is, so 4Zn plus NO3 minus. NO3 minus was coming from NaNO3, and here coefficient is 1, so only 1 NaNO3 plus OH minus. OH minus is coming from NaOH, so it will be 7 NaOH, giving Na2ZnO2, 4ZnO2 2 minus are there, so it will be 4 Na2ZnO2, and NH3 is 1, only one coefficient is there, so only 1 NH3, and water is 2. Okay. Now you check one more time. 4Zn, sodium 1 and 7, that is 8, 4 into 2, that is 8, and 1 nitrogen, hydrogen are 7, so here 3 and 4, 7, oxygen 3 and 7, 10, here you see 4 into 2, 8, and for water we are getting 2 oxygen, so overall 10 oxygens in the right hand side. So all are balanced. So once you are satisfied that everything is balanced, we can remove this arrow sign and we can place equal sign. Okay. This is the balanced reaction of the given reaction in alkaline medium. So I will make more such videos. So if you are interested, especially if you are students, then you can subscribe my channel to get this type of videos more. And that's all for this video. Thank you all for watching my videos.